We're going to try to collect some GCMS spec data on the product for the Diels Alder reaction. So brought over the 56R vial, and I'm putting that in slot number 1. Now we don't have a method file for the Diels Alder reaction, but we're going to try the same method file that we did for the reaction of morpholine with T-butyl acetoacetate. It's a general method that's fairly useful, rising from 80 to 245 over a period of about 6 minutes or so, at a decent flow rate. So what I'm going to do is I'm going to use the method called morpholine solids, which is already open, and I'm going to log in my sample, and this sample is 56R, first piece of data on it. So DCL-10-56R-1, and I'm going to save that in my folder under data. I can find my folder. I'm going to put that in the GCMS folder under 2020-21 labs, and I'm going to call this the Diels Alder product. Not 100% certain what it is, of course. It's in vial number 1, an injection volume of 0.1 microliter should be good. I'm going to tell it I want to do an integration, but I'm not going to do a similarity search because the product is almost certainly not in there. And under data description, this is the product of Diels Alder reaction between 1,3-cyclohexadiene and N-phenylmaleimide. So I can OK that, and then I can download parameters, and that will send that information over to the sampler. And it's the standard sampler conditions that we're used to, with 2 washings with dichloromethane, since we dissolved this in dichloromethane, just as we did for the morpholine solids, and then 2 washes with sample, pumping a couple of times to get rid of air, and then doing a 0.1 microliter injection. So we can let that run, and it should automatically start once it has adjusted the parameters. So you can see that the arm is going and collecting that sample from slot 1 and moving it over. And I'm really not sure what we're going to see here, because I don't know what the if the product has a suitable volatility to come off under these column conditions. But it's a good starting point, and it works well for a variety of solids. You'll notice if you compare the GCMS method that for the last lab of the semester, the bromination of acetanilide, the conditions for the running of the sample are identical as they are for the morpholine lab. So we're going to hope that identical conditions will also work for the Diels Alder lab. So this will allow me to observe what happens. I click on the method detail, and it allows me to look at all the details of the method, puts it into a full screen. But if I click on the method detail again, it will allow me to look at the sample as it comes off. And we're getting that carrier insert warning every time, which we're just going to ignore. So we've started the run. Retention time is 0.179, right? But the data will not start collecting until 2.1 minutes. We have a 2-minute cut time. Hopefully our product will not come off in that 2-minute cut time, because if it does, we won't see it. Just return to the sample. It's done washing the syringe. So this could be really unexciting. We could just get a flat baseline and nothing comes off at all the whole time. Or we could see a product anywhere between 2.1 and 10 minutes. So while that's happening, I'm going to go and dispose of these 2 morpholine samples that the GC has finished running in the waste container. And those are just glass waste from disposable vials. Hopefully I got my camera angle right so you can see what's coming off on that screen pretty nicely. We'll see, I'll just tweak it a little bit. I think that's pointing at the screen. So it's been 2.1 minutes and the red line has started to come here as the data is collecting. And we hit that blank at 80 degrees. We held for 2.5 minutes, and for the first 2 of those we didn't collect data at all. Now we're just going to see what happens. We do know that this product comes off a GC column because we followed this reaction by GC. But it may require a higher temperature to get it through this longer column. This is a 30-meter column, and that was a 15-meter column. And we also are not entirely sure what our flow rate was. We're at 1.19 milliliters per minute here. But we're not exactly sure what the flow rate was on the GC because the split was 6 terms open. And that may or may not correspond to a split of 25, which is what we have it set here. So we're rising fairly rapidly. We'll see the temperature of the oven is now 116, now 119, and it will hit 245 and then stay there for 2 minutes. So hopefully, even if the lower temperature is not good enough to get this compound through the column, once we hit that high temperature. Remember that the total run time was only 3 minutes for the gas chromatograph that we followed this reaction with. But we were running at a fairly high temperature, much higher than this 80 degrees that we started at with this one. So I wouldn't necessarily expect it to come through quickly, but I am hoping that it comes through. I should be playing suspenseful music as we watch that pink line progress across. 6 minutes in and nothing yet. Our oven is now up to 184 degrees, which is quite warm. It's got another 2 minutes before it hits that maximum temperature of 245. On the bright side, we've seen nothing over those first 8 minutes, and it's likely that both the N-phenylmaleimide and the cyclohexadiene would have come off already. So it appears that we probably don't have any of the starting materials. And now we've hit that maximum temperature of 245. And we've got 2 minutes. Hopefully the product comes off. Got another 60 seconds. It's highly unlikely that the compound was volatile enough to have come off in the 2.5 minute or the 2.1 minute solvent cut time. So if we see nothing here, the logical thing to do would be to dramatically increase that initial temperature. So we're running for a longer time at the higher temperature. It looks like perhaps it's not volatile enough to have gone through this 30-meter column at a flow rate of only 1.19 milliliters per minute with that low starting temperature, because we reached the end of the run and seen nothing. So we'll go back to sample login. Actually, we won't do that yet, because we want to modify this method. So we're going to save this method file as Diels Alder 2021. We're going to change that initial temperature from 80 to 200. And we'll rise at 30 degrees C per minute. Well, sorry. We'll hold it for about 2 minutes at 200. And then we'll rise at a slower rate. We'll rise that at 15 degrees C per minute till we get to 245. And then we'll put a hold time in there about 6 minutes, which should be plenty long enough. If you look at our method detail, that's now an 11-minute run. That should be plenty long enough for this material to come off, even at that column flow, which is now slightly decreased. So I'm going to change that column flow to 1 milliliter per minute, because at the higher temperature it flows more slowly, and that's going to increase our pressure to 111.4 kilopascals. 25 on the split ratio is probably still good for the concentration of sample we made, and that linear velocity is now 38.7. We're going to leave everything else on the mass spec side, or the sampler, unchanged, but now on the mass spec our end time needs to be changed to 11 minutes so that we see data for that full size. And I'm going to change the Coleman cut time from 2 minutes to 1, and the start time here to 1.1, because at that temperature I'm pretty confident that the solvent is going to come off in the first minute. So we'll save that method file. And now we will go back to sample login and change this from 56R1 to 56R2. And we will change our file name to Diels Alder product round 2. And download parameters again, and this will run that second sample a lot hotter for a lot longer, and hopefully get our compound to come off. We're going to be sitting at 245 degrees for a good long time, and we know from the gas chromatography that at that fairly high temperature the Diels Alder agar does come off. So we'll just let that run and come back when it's done.